Alright everyone, welcome back to my workbench. I had to mess with my setup a little bit because for some reason my OBS decided to stop outputting color on my main camera. So I'm just using a quick snap program to capture video instead. Tonight it's not too thrilling. It's just doing some cap replacements on the CDX. So as you may have seen or heard, I'm kind of trying to get out of the retro repair business a while. Just kind of, I have some projects which have been of my own that I've been able to work on in close to 3 years, so it's probably time to focus a little bit on more stuff I want to do. So thank you to everyone that's been so supportive for the years, but I kind of need a break and catch up on some of my own things and work on some other interests. Not that I haven't had a lot of fun doing this, it's just after a while you want to branch out into something else. It's just a bunch of cap replacements. This is the power board on the CDX. I've never done one of these before. Yeah, these are... The whole thing is you want to not overstress these boards too much. That's a fat cap, my goodness. Sometimes I find I have to kind of, like, I wouldn't say pry them out, but loosen up the solder on one side, then a little bit of a pull the leg up a little bit, then pull the other leg up. Or you just go for it, and if you have a room, which I don't hear, if you want to replace caps real quick, it's impossible. This style, and this is, you can't do it either. But like on the Genesis, what you can do is you could just clip the legs off, and then go ahead and clip the legs off, then use your solder removal tool to clear out what leg is left in there, and go from there. Yeah, these are stumpy little things. Wow, they really got it on there. Now, if you're wondering on this kind of board, all this is you have a power regulation circuit, and they got a couple inductors on here, which means they're using the boost circuit on it. Whenever you see inductors, what they do is they take the DC signal coming in, you send to a high frequency AC, and then you can boost the voltage that way, and then you rectify it again, and you get DC again. Nowadays, you just have one. You can have one little chip and a couple of inductors is all you need to do it. Little boost converter. You can do with buck converters the same way too, but it's amazing how small some of the circuitry is. Now this is that's a little tiny, is this a boost or a buck? I can't remember what this is. But you can see just how tiny like a little boost converter can be nowadays. Everything's all integrated on one chip. This is actually adjustable too, kind of cool. But you can get an idea just how small the components are now compared to what they had to do back 25 years ago. Try this again. Yeah, it's mostly clear. That's not bad. What you can do, since I'm here, I can just, you can see the leg itself. See how there's still two little legs left there? I can go in and snip that off, and then I can see if I can get the. I still want to damage the pad. That's the main thing. Yeah, see, that's even then that's a little close. I don't like that. So after the CDX is done and the Nomad's done, I still haven't gotten any information back on the Nomad's. Why I'm not getting a the controller one isn't working yet. A little frustrating. I might have to open up the controller itself and figure it out what's going on there. And then this guy doesn't want to come at all. As you can see, replacing capacitors isn't all that sexy or exciting. When I spread the legs on the cap too, makes it a little bit harder to pull it through. Let's try that again. This is thin FR4 too. This is not very thick at all. It's a thin board, and I don't want to flex it too much. How thin is this board? It's only 1.2 millimeters. It's a thin board. Conventional board, we're up to 1.24. These are pretty thin boards, actually. And there's just not a lot of mass to it. Okay. Well, I'll go tackle these caps for now, and hopefully I'll get these pried out in a minute. And then there's only 1, 2, 3, 4, 5, 6 caps on this board, so that's not bad. I'm going to check my video quality and then I'll see if I can upload this. Okay, so hopefully this video could splice together okay. What I'm going to do is, I did figure out a way to get my OBS to work again. I don't know why it wasn't. And then how to get these large caps out of here. So it looks like the easiest way on this particular board as I'm doing is taking the, I'll show you here in case anyone else has to recap one of these. A little different technique that I'm used to because I can't really get under it all that much. Because otherwise I usually just kind of lazy and just clip the leads and pull it off. In this case, I had to do a modified thing where I came in here. This is the leads I just capacitor legs I just desoldered. So I'm going to go through and step them back. I gotta close my eyes when I do this because it kind of flies right in my face when I do it. But that seems to get it to the point where it either almost falls out or I can just heat up the leg a little bit and get it out without too much trouble. I'll give it a little bit of a wiggle here. Yeah, I don't know what was going on there. I think the audio was not all that great using the Snap program anyway. So I'm just going to see if I can get this cap out of here. Yeah, it's pretty loose. I can feel it actually. Still want to damage those inductors next to it. you can come out. A little bit counterintuitively, if you don't get all the solder out, you add some solder back into it. Otherwise, you won't get the solder to flow all the way through. So when you go to melt the solder and pull it out, you just won't get good heat conduction, and you'll be kind of stuck with fighting getting that solder out. This is one of the trickier recaps I've had to do. Usually it's pretty straightforward and they just kind of more or less fall out. This guy, on the other hand, is not wanting to cooperate very much. Clip that lead back even further. Always have a good set of diagonal cutters if you ever go into this. Invest in halfway decent tools, or you'll regret it. You'll be fighting your tools all the time, and you'll just get frustrated. Anywho, let's see if I can get this out. This one leg just doesn't want to come. Because the other one, there's not much contact there at all. Probably run into a lot of times with capacitors is the negative leg will be quite a large heat sink, and you have a hard time getting the solder to really flow. Yeah, I think I'm not gonna miss doing all this. A couple neat. I have a portable game console I've been working on. I haven't been able to work on. There's a Tiger Gamecom I want to retrofit with a Raspberry Pi. There's a of course I have like 15 watches I want to review. So I collect mechanical wristwatches. I've never tried a video review. Maybe I'll try that. I don't know if it interests anyone watching this, but it interests me. It's kind of ironic because I'm an electronics engineer and I love mechanical watches. I don't own a smartwatch. I don't even own that many quartz watches, actually. But I came from a generation where everyone wore a watch. Come on. Oh. So, I remember when I was a kid, I think I was about 14 years old. I was bugging my parents like every 10 minutes to get a nice analog quartz watch. Because even by that time, I was about, 87, 88. And not only was the quartz revolution way deep into that, there was also, it was getting hard to find just an analog watch because they were just, it was digital watches. And believe it or not, I really can't, I can't read digital watches all that well. They just, I can't really tell what time it is that easily, as I learned on analog. So it takes me a couple seconds staring at, okay, 1150. Oh, I don't know what that looks like. It doesn't click in my head quickly. Because I can just glance at an analog display and I know, oh, it's 1038 right now. And just never got used to it. I have a couple digital watches just because because they're classics. Like the Casio F91, that's a cool one. The classic cheap ass watch. And mostly because it's an interesting piece, and it's inexpensive. And if you need something with a lot of shock resistance, it's can't go wrong with digital. But again, I don't really care for them all that much. There's no real life to them at all. It's just a little computer that happens to tell time. Like smartwatches, I can't get into those at all. It's just the whole thought of having to like charge my watch every night, worried about my watch running out of power. Like this watch, I mean, it's automatic. It's just me moving my wrist winds this watch up. I don't even have to think about winding it. Let's see. Yeah, the problem with these big 470 microfarad caps is the cap itself has a lot of mass to it, so when you go to desolder it, it takes a bit of heat to get it the flow. I don't want to accidentally reflow or tombstone there's a couple surface mount components sitting right next to it. I can see there's a regulator here, a regulator right there. I don't want to accidentally damage those. Now for watch reviews, I think I'm just going to use like my DSLR for that instead. Get better lens. So that might be coming up soon. I don't know. I still have quite a few electronics projects of my own I want to finish off first. I got an Atari, my own Atari Lynx, one of them. I have two of them. One of them needs some repair. And then, of course, the Tiger Gamecom, I want to do that. And my own version of a Nintendo Switch I've been working on. That's got a 7-inch screen on it. I'm mostly done with. I just hadn't had a chance to finish the battery circuit on it yet. Okay. That's enough desoldering for the night. It's already 10:40 at night. I'm going to splice these two videos together, and everyone, thanks for watching. Once this is done, these big caps are done, these little ones will be a piece of cake, and these little guys over here will be quick too. I might show that, I might not. And then after these are all done, then it's the more interesting, there's more recapping of course, but then the swapping out the laser transport. So that should be in a day or two. I'm going to work on this without worrying about talking, and it shouldn't take too much longer. And then recap this. I don't think I'm going to show recapping this. That's not going to be exciting at all. And then today's Monday, probably Tuesday, Wednesday, I'll get into replacing the laser transport. It's not the transport, the pickup itself. And that should be interesting. I've never done that before, but I'm going to rewatch the video one more time and then jump into it. So everyone, thank you for watching.